Hello! In this video, I'll be summarizing the various tech demos within my custom renderer s3d. It started off as a means for me to improve as a graphics programmer and is actively used in my classroom at Georgian College for my students to also become better graphics and engine programmers. So let's take a look. If we start off, we can fly directly into the sun. We realize it is far from a perfect circle. That is because this demo is a hybrid rendered scene where you can toggle between rasterization and ray marching. So we're currently ray marching mathematically perfect spheres using distance fields. Unfortunately, the asteroids are not ray marched. However, the main challenge in this scene was unifying the depth buffers. So we have linear depth in camera space in the ray marched pipeline, combined with a perspective projected logarithmic depth space from rasterization. So I converted the ray march depth to the expected logarithmic space, and we can see that if the planet passes through an asteroid, it should be some pixel perfect intersections. Oh, that one's so close, but you'll just have to take my word on that one. There we go. And again, maybe some future improvements could be using domain repetition to procedurally remarch all of these asteroids, but this also served as an instance rendering demo. I can jack this up to at least 100,000 asteroids and the frame rate remains stable. So there we go, instance rendered hybrid scene. Next, we have a deferred lighting demo. So one sec, let's remove the debug panel. So there is the final compositive scene. We can see a beautiful blend of warm and cold colors with some nice diffuse and specular highlights on some buildings. We can break down our scene with debug tools. So as you know, we've got albedo, position, normal, and the compositive scene as frame buffers. Furthermore, we can verify the light wireframes to see the specific screen space pixels that are actually being sampled to calculate the lighting contribution. And if you didn't have enough lighting to your taste, we can add some direction light. We can change which way we shine it from. So there you have it. And of course, we can select its color. And we can even toggle between whether we render our ground versus our buildings. So fun fact, this hexagon grid is actually generated procedurally, where I just used a fragment shader to write to a frame buffer once, and then we can sample it on repeat as a texture. So speaking of procedural generation, if we hop into this scene, the reflective paint scene, you'll notice that the cars changed their color depending on the direction that we're viewing them from. This is especially noticeable in what I like to call our galaxy car. It's really just doing environment mapping, where we combine either a cube map rendered as a spherical gradient of respectively warm and cold colors, or our skybox that was preloaded in our outer space scene. And then we also combine it with this sort of Arctic themed skybox to achieve very cool reflective cars. So if we break this down, we can see here's our galaxy skybox in isolation. Here's our warm skybox, cold skybox. And then if we select our cars, we can tweak the intensity. So we can see that if we can maximize the paint intensity and minimize the environment intensity, then the glass will become fully opaque because, well, I don't know about your car, but I personally do not have paint on my windows. And then vice versa, we can minimize the paint and make it just the reflected Arctic skybox. So that just sort of breaks down the compositing. We can, toggle our ambient, diffuse, and specular. They're already as specular as it gets. So there you go. Vroom vroom. So those are the main rendering demos, I like to play around with ray marching. I think it's a very neat way to learn graphics programming, as it doesn't require the full-on hardware accelerated pipeline. So we can see just a demo of some 3D shapes right here. We've got some domain repetition going on right here, just marching a bunch of octahedrons and then changing their color based on distance using a really neat palette function. Whoops. Then we've got this fractal, as well as this sort of morphing, I don't even know what to call it, but some very fun ray marching demos. Now we've got a couple test scenes. So in the early stages of development, I had to make sure all my vertex data was correct. So I just have a bunch of meshes to choose from. Those ones you can't see because of backface culling. And we've got different effects that we can apply on them, so we can validate with wireframe rendering. Let's see. Can do grayscale depth, world space position, screen space position, object versus world space normals, texture coordinate validation. So yeah, very handy little debug tool. We also have a physics test, which is just a ball pit, so we can see restitution at play and, a bit of gravitational acceleration pulling the objects downward. Got a collision test where I have different types of geometry, including circles, capsules, rectangles, and planes. So a plane sort of cuts your space in half, so we can see that its edges will eventually push this rectangle around. And if that wasn't enough, we actually have some CPU-based demos. So we've got a raycasting demo where we can, the top is kind of confusing to look at, but the background is a top-down render of the map. So we can see we've got this red line extending from the player, and we can see, well, we actually marched like however many rays fit in our field of view, but this single ray intersects with the blue tiles, so we can see sort of some blue tiles on our direct line of sight, and then we've got some green tiles, more blue. We can kind of just walk around like so we can see that we're very close to a red tile, so we see a plethora of red pixels go right up to green. It gets bigger, otherwise the distance is longer, so the rays get smaller. Kind of fun. And then these demos, this is the bulk of my second graphics programming course, so I will link a course summary to that in the description for a much more technical overview. But we've got some gradients, some geometry, and this is basically the final week of the course. We end up with a full-on software rasterized image, complete with Phong shading and texture sampling. So hope this was interesting. Thank you very much for listening. Take care.